Welcome to section 4.2, part 2, graphing. This is where we're going into slope. Now before we actually calculate, I'd like to do a little talking about slope here on this picture. We have four options for a slope: A, B, C, or D. And the way I like to think about slope is from left to right. So here's my graph, my two axes. I put a little skier here, and I usually draw my little skier on the left side of the line. Here, and I always ski from left to right, just like I read, just like the number line is going from left to right. So he's right here, and he has to move from left to right, and he has to be on the line. So in this case, if my skier is on this line, he has an incline, so he has to climb up here or hopefully have a ski lift to go up. This means it is a positive slope. So if in your calculating you get something negative and in your graphing you're getting positive, you know something went wrong. Another thing is the slope here. Remember, he's always on the left side and he goes from left to right. This one's perfect for a skier. It's going downhill or the slope is negative. If I put my skier again on the left and move him to the right, in this case, we hope he has cross-country skis because it's just flat. He doesn't get any speed, no, it doesn't have any altitude, which means that the slope is 0. So he doesn't even get to move unless he moves himself. So it's just flat. Now if I put my skier on this one, it's a cliff. He has a parachute. And the way I like to remember this, because as soon as you put a skier on there, you can imagine this being 0, and this one is a cliff, and the skier has sudden death. In this case, not really because it goes on forever, but he's falling, and one way to kind of remember that in a kind of an ironic, funny way is that this slope is undefined. So I can't ski on this one. So that's how I like to remember those. And if you're getting something different in your calculations than what you know about the pictures now, then go back to your calculations and see what went wrong. And this is help to show you with something of part 2. We're going to come back into here though and do some calculations by hand first, and then I'm going to maybe teach you a trick that the other teachers might not appreciate, but I think it'll be fast. So here's what we're going to do. To find slope, you were told in the text m equals y sub 2 minus y sub 1, all divided by x sub 2 minus x sub 1 equals m, or slope. And while I think this is very relevant, it tells you that this right here was an ordered pair, and this right here was an ordered pair with the x's on the bottom and the y's on the top. A lot of students get confused with the sub 2 and the sub 1. This just means that I'm taking one of the points, and a lot of them get confused and say you have to use the second point first and then the first point on the second part of the equation, which is wrong. You can reverse them however you want, as long as, and I'm going to put a shape in here, as long as these two form, and I'm going to, as long as those two form an ordered pair. Always double check that, because if you get those mixed up, and you crisscross these, you have the wrong slope because you don't have your ordered pairs lined up. So always make sure of that, and then you don't have to remember the sub 2 and the sub 1. It's up to you if you want to. Some of you are analytical and would rather do the sub 2s. Those of you who might not be as analytical, then just think, maybe put those ovals on so that you make sure that you're getting the ordered pairs on top of one another. And another way I like to remember this is the definition of slope is rise. I'm going to put this in here. Rise over run. And what that does in my mind is rise means how far up and down I'm going. So I'm rising something. And that again goes back to y being the tall letter. So rise means I'm doing the subtraction of the y's on the top. It even kind of rhymes, rise and y's. Then run, I run in a horizontal fashion. So this is where I subtract the x's. And that's another way to help remember where what subtraction goes where and what divides what. So I've already set up something over here using my insert equation. If you haven't seen that, maybe go back and look at one of my other tutorials or video lectures on how to set that up. You go in, you insert, I added the fraction and some brackets. All right, now that I have it kind of set up, I'm just going to start throwing in my numbers to help speed us up through the process of calculating all of these. Now don't forget, the ordered pair has to have matching, either the front or the second. I'm going to go ahead and stick with the actual equation, the formula which has the sub 2 there. So I'm going to go with my second y and subtract my first y, which is 7. So subtract 7. Then on the bottom, the second x is negative 6. Subtract the second or the first x is negative 4. And then I have to look at when I have a negative and a negative, that's a positive. So I have negative 6 plus 4 makes that negative 2. Then I have negative 4 minus 7, that's negative 11. And then I have negative 11 over negative 2, and negative divided by a negative is positive. So I have 11 halves, and there we go. And these, because slope is rise over run, keep these in improper fractions. Do not change them. It's not really an option to change them to a mixed number because we want to see rise over run. So leave them as improper fractions at all times if it's an improper fraction. If you can simplify it down to a whole number, then that's fine as well. Okay, number 2. I'm going to show that it doesn't matter. I can then reverse these and do y1 minus y2. I don't like to think of it as that, so I just take one of the x's and I subtract, or one of the y's and I subtract the other y. So in this one, I'm going to do my 4 first. 4 minus the other y is negative 2. And then make sure you find the x with the 4, which is 10. And I'm going to double check this. 4 and 10 are an ordered pair? Yes. So now I can throw in the other x, which is negative 2. And in this case, it's kind of nice because my negatives here make this 4 plus 2, which is 6, and 10, the two negatives become positive, so 10 plus 2, which is 12. And that simplifies to 1/2. And that's my answer. So again, it doesn't matter as long as they line up. If you're one who finds that you need to keep the y2s and the y1 and the x2 and the x1 in the same spot, that's fine, it's up to you. However, I'm going to just choose whatever happens. So in this one, I'm just going to pick, we'll do the 5, and so the 5 was the y. I need the other y, which is negative 10 minus 10. Then I come back, the 5 matches the 2, put the 2 here, 2 and 5 are the ordered pair. Negative 10 comes with the 2, and there we go. That becomes 5 plus 10, which is 15. 2 minus 2 is 0. Now, some of you are okay with this, knowing that something divided by 0 is undefined. But if you wanted to have another way to just verify that, plug it into your calculator and it'll say there's an error, which is true because you can't divide by 0. So that's another way to check, and on a scientific calculator it will do the same thing. It'll come up and it'll say error. whenever you see that, you can say undefined. And undefined, do you remember what it looks like? We talked about it earlier. An undefined slope, if I put a skier on an undefined slope, it's vertical. So we hope that he has a parachute and he's going to fall the entire length of the line, which, lucky for him, goes on for infinity. All right, let's try the next one. Here I'm just going to pick this y. So 3. Find the other y. It's 3. And then the x that goes with my first 3 is 19. The x that goes with my second 3 is 20. Some of you are already knowing what's going on here. 3 minus 3 is 0. 19 minus 20 is negative 1. 0 divided by anything is 0. And so if you see that your y's are the same, you don't even have to go through the bottom calculations because 0 divided by anything will be 0. And the 0 slope, it looks like a flat line. So we have this skier that hopefully has snowshoes or cross-country skis, and he has to walk because he's not going to go up or down. It's a 0. And for some reason my answers for my other page came up. So we'll fix this quick and move on to problem number 4. Okay, moving on to this one. So we have y minus y. So let's pick the 5. So I'm going to put the 5 here. 5 subtract, the other y is 2. Double check what x goes with the 5. In our case, negative 7. Okay, so those match up. Then 2, I need it over the 12. And we can subtract. 5 minus 2 is 3. Negative 7 minus 12 is negative 19. Nothing goes into both 3 and 19. However, this negative can't stay on the bottom. So I think to myself, positive divided by a negative is negative 3/19. And there we go. And that's the answer. So this one says that I rise a negative 3, which really means that I'm falling 3 from one point to the next point. So I go down 3 and then to the right 19. And that would be the rise over the run. Okay, let's move to number 6. Number 6 says find 2 points on each line and use it to find the slope. And like in part 1, my favorite ones to plug in are the x and y intercepts. So I just plug in 0 because it makes it so much faster. So I don't have room over here. Well, let me come over. Nope. We'll have to do it on this line. Okay, so when I put a 0 in for x with my parentheses, that means that this whole part is gone. And I'm left with y equals negative 4. That's why it's my favorite to plug in these zeros. Now, put my x back in here. And if I plug 0 in for y, I'm just going to delete that because it's 0. And I have negative 2 equals negative 4. Negative 2x equals negative 4. And divide both sides by negative 2 gives me, oops. Oh, the formatting got all off here. Divide that by negative 2 gives me positive x equals positive 2. There we go. So now I can throw those into my formula that I did before, subtracting the x's. So I'm going to do 0 minus negative 4. Don't forget, this x needs to be the one that came with the 0 for the x. or the 0 for the y. So I do 2, and then I have negative 4 for the y, so its x was 0. And 0 minus a negative 4, those become positive, so that's a positive 4. 2 minus 0 is 2. 4 divided by 2 gives me a slope of 2. There we go, and let's delete that so that things get back on track. All right, let's try the next one. Again, I'm going to throw in the 0 and the 0. Putting a 0 in for the x. I'm just going to do this one in my head now. 6 times 0 is 0, so I have 2y equals 24. 2y equals 24. So if you need to use your finger, cover up the 6x. And to solve this, we divide both by 2, which makes y 12. Now the next one, I'm going to cover this one up because I plug 0 into here. 2 times 0 is 0. So I have 6x equals 24. Divide them both by 6, makes the 24 4. There we go. And again, we throw these into our equation. So 12 minus 0. 12 goes with the 0 first, and then the 0 for the y has the 4. So I have 12 minus 0 is, 12. 0 minus 4 makes negative 4. Positive 12 divided by negative 4 is negative 3. And we should highlight that as being the answer. And we forgot to highlight it on this one. Okay, let's move to the next one. 8. We're going to plug in 0, 0 for x, 0 for y to find the x and y intercepts. 0 here makes this term 0 because 0 times negative 2 is 0. And I'm left with 3y equals 24. So divide by 3, and I get 8 here. Then I plug 0 in for y. 3 times 0 is 0. So I can ignore this term now. And negative 2x equals 24. Divide that by negative 2 makes negative 12. There we go. And putting these in our formula, 8 minus 0, so that was y minus y, equals 0 minus negative 12. This was y for, or 8 was y on this one, and it coordinates to the 0. Good. And 0, negative 12. So double check those, and 8 minus 0 is 8. 0 minus a negative makes that positive 12. And then divide both of those by what goes into them? 4. So I have 2 over 3. And it seems that I have a negative 2/3, so let's just double check and see if I did it wrong previously or just now. So I have 8 subtract 0 over 0 minus negative 12. It seems I did that one wrong. So that should be a positive 2/3. All right, and highlight that as the answer. And let's move to the next one. 9. So again, we're going to do 0 and 0. 0 substituting in for x cancels this term, and I'm left with negative 3y equals 30. Divide both sides by negative 3, and that leaves me with y equals 30 divided by negative 3 is negative 10. Then put a 0 in for the y. 0 times negative 3 is 0, so I can ignore this term. I have negative 5x equals 30, so I want to divide both sides by negative 5. 30 divided by negative 5 is 6. If you're doing this on your own paper to follow along, I suggest that you write down all of these steps. I'm simply not doing it because of the formatting here. All right, so now I have negative 10 minus 0, and then the x that coordinates to the negative 10 is 0, 0 minus 6, and that gives us negative 10, and 0 minus 6 is negative 6. A negative divided by negative is positive, and both of those can be simplified by dividing by 2. 10 divided by 2 is 5. 6 divided by 2 is 3. So our answer is positive 5/3, which again I have as being negative over here. I'm going to double check because I think I must have written it down incorrectly. So we have, oh, negative 6 is what I have. So let's double check here. A little troubleshooting. So if I put a 0 in for y, yep, positive 30 divided by negative 5 is negative 6. I apologize. Let's go back and fix that, which makes this negative 6. It's kind of good to see this so that you know that you can just go back through and a negative sign can change the whole problem. There we go. That feels better. So I made the mistake on this one, not previously. All right, let's move to the next one. Okay, so I have, again, my 2 points I'm going to pick are the x and y axis, 0 and 0. Plugging a 0 in for x makes this 0, which means y equals negative 5. Now if I put a 0 in for the y, it's a little, and I'm going to come over here and actually plug it in since there's going to be a little bit more scratch work on this one. So I need to put a 0 here. And normally I would be going down, however, I can't use this space over here. So to isolate the x, I need to add 5 to both sides, which makes this 0 plus 5, which is 5. And negative 5 plus 5 is gone. It cancels out. And then to isolate the x, we need to multiply by, or divide by 5 halves, which is the same as timesing by 2/5. So I'm going to times that by 2/5. I guess we'll come up here and do 2/5 times 5 halves. 2 times 5 is 10, 5 times 2 is 10, 10 divided by 10 is 0, or you can think of canceling those out, which gives you just x. And then I need to times this on the left side to keep it balanced. And 1 5 on top and 1 5 on bottom will cancel. Another way of thinking about it is numerator times numerator is 2 times 5 is 10, divided by 5 is 2. So this cancels out, and these 5's cancel out, which leaves me with x equals 2. Okay, so let's plug these in here. And my y, let's do the 0 first, just because. 0 minus the negative 5. If I did this 0, I need to do this x first. So that one will be 2 minus 0. 0 minus a negative 5 makes that positive 5. 2 minus 0 is 0, or it's 2. So we're done. That one doesn't even need to be simplified. So let's highlight that as our answer. And there we go. So that's how we can do it by hand. We can also be using our calculator on the side. And I'd rather, if you were a little uncomfortable with some of those calculations, to go ahead and use your calculator so that you can focus on putting the correct and use your energy on finding the slope and putting the correct ordered pairs together. Now I'm going to teach you something that's really fast and maybe even a little naughty. So what I've done is I've copied my x and y's from all of these, and I've put them in some tables. So these are all of my coordinates from 1 through 10, and I've put them over here in separate columns. And I just highlighted these with different colors so that I would keep those separate. And what I can do here is type in my formula, which will be parenthesis y minus y, and it doesn't matter, so I'm going to just pick a y, subtract this y, close the parenthesis and divide by parenthesis. Make sure you're going in the same order. So I picked this y first, so I'm going to pick this x and pick the second x for the second one, close parenthesis, press enter, and there's my slope. All right, and because I've done some cell references, I'm just going to click and drag, and there's my slope for all of them from 1 to 5. So that was kind of a sneaky way of doing this. Again, they aren't in fractions though, so what I'm going to do is I'm going to come and format my cell and do fraction. And because some of these might have more than just one digit, I'm going to go up as high as I can, and there we go. We could do 5.5. However, like I said, slopes you don't want to keep as mixed numbers. You'll want to change that to an improper fraction. To do so, you take the denominator and times it by the whole number. 2 times 5 is 10, and add the numerator, which is 11. So that's 11 halves. Oops. Let's reformat that as a fraction. There we go. And we need more than 1, so now we have 11 halves. And it's going to continue to do that. Oh well, let's move on to the next one. Down here you'll notice it's kind of giving you an error, a number divided by 0 with an exclamation point, saying, hey wait, something went wrong here, so you need to interpret this as undefined. And then I can do the same thing here, equals my y minus y, and I used my first one, so I'm going to keep track of that in my head so that when I subtract the x's, I use my first x, minus the second x, and there we go on these ones, and click and drag, and I have those. Again, go back and format as a fraction, and there we go. And so when you write these ones down, you'll want to change those back to the improper fraction by multiplying bottom times the whole number at the top. So 2 times 2 is 4, plus 1 is 5, so this is 5 halves, and so forth. All right, well, good luck on your homework. Thanks for sticking with me through part 2 of section 4.2.